In today's lesson, we'll be learning about the primary trigonometric ratios, also known as SOH CAH TOA. If you recall, SOH CAH TOA is a mnemonic which helps us remember the three primary trigonometric ratios. Sine theta is equal to opposite over hypotenuse, cos theta is equal to adjacent over hypotenuse, and tan theta is equal to opposite over adjacent. It is important to remember that the hypotenuse is always in the same position. It is the longest side, and it is located across the 90-degree angle, which is indicated by the little square. However, opposite and adjacent are relative terms. It depends which angle you're taking the point of view of. For the triangle to the top, this would be the adjacent side, and this would be the opposite side. Meanwhile, in the triangle to the bottom, this would be the adjacent side, and this would be the opposite side. In our first example, we want to find the measure of angle x to the nearest degree. This is angle x. Let's call it theta. That would mean the side labeled 15 centimeters would be considered the hypotenuse, since it is the longest side and it is across the 90-degree angle, and the side labeled 11 centimeters would be the adjacent side. The trig ratio that contains adjacent and hypotenuse is cos theta. And let's write it down. Cos theta is equal to adjacent over hypotenuse. Next, we want to substitute in our known information. I do not know what theta is. That's what I'm looking for. So let's leave it as is. Adjacent is 11 and hypotenuse is 15. I can't do anything with the left side of the equation, so I'm going to leave it as is. Meanwhile, 11 divided by 15 is approximately 0.73. Remember, I want to figure out what theta is equal to. However, theta is stuck with this cos. To get rid of it, you need to do the inverse cos, and it looks like this. There's a -1 right above it, and the 0.73 looks exactly the same. To access the inverse function, you either need to press a shift button, an inverse button, or a second button. It really depends on the type of calculator you have. Therefore, the cos inverse of 0.73 is approximately 43 degrees. So let's make a concluding statement. Therefore, theta is 43 degrees. In our second example, we want to find the measure of angle P to the nearest degree. So let's label it theta. That would mean the side labeled 8 centimeters would be adjacent, and the side labeled 5 centimeters would be opposite. The trig ratio, which contains opposite and adjacent, is tan theta. Let's write that down. Tan theta is equal to opposite over adjacent. Next, we're going to substitute in our known values. Since I do not know what theta is, I'm going to leave it as is. Opposite is 5, and adjacent is 8. I cannot do anything with the left side of the equation right now, so I'm going to leave it as is. 5 divided by 8 is approximately 0.625. Remember, we want to figure out what theta is equal to, but it is stuck with this tan. So we need to do the inverse function. So we're going to use tan inverse. There's a little -1 in the top right corner. And you're going to need a scientific calculator to do this. And tan inverse of 0.625 is approximately 32 degrees. Let's make a concluding statement. Therefore, theta is 32 degrees. In our third example, we want to find the measure of angle T to the nearest degree. Let's label angle T theta. That would mean the side labeled 3 meters would be the adjacent side, and the side labeled 10 meters would be the hypotenuse. The trig ratio, which contains adjacent and hypotenuse, is cos. So let's write cos theta is equal to adjacent over hypotenuse. Next, I'm going to substitute in my known values. Since I do not know what theta is equal to, I'm going to leave it as is. Adjacent is 3 and hypotenuse is 10. I cannot do anything with the left side of the equation, so I'm going to leave it as is. And I'm going to take 3 and divide it by 10, and that's going to be equal to 0.3. Next, we need to do the inverse function. So I'm going to do cos inverse of 0.3. And cos inverse of 0.3 is approximately 73 degrees. So I'm going to write a concluding statement. Therefore, theta is 73 degrees. In our fourth example, we want to find the measure of angle t to the nearest degree. So I'm going to label angle t theta, which would make the side labeled 5 meters, the opposite side, and the side labeled 11 meters, the hypotenuse. The trig ratio, which contains opposite and hypotenuse, is sine. So I'm going to write sine theta is equal to opposite over hypotenuse. Next, I'm going to substitute in my known values. Since I do not know what theta is equal to, let's just leave it alone. Opposite is 5 and hypotenuse is 11. I cannot do anything to the left side of the equation, so I'm going to leave it alone for now. 5 divided by 11 is 0.45. At this point, I want to isolate theta, so I need to do sine inverse to 0.45. And sine inverse of 0.45 is approximately 27 degrees. Therefore, theta is 27 degrees. In our fifth example, we want to find the measure of angle A to the nearest degree. So I'm going to label angle A theta, which makes the side labeled 3, the opposite side, and the side labeled 5.83, the hypotenuse. The trig ratio that contains opposite and hypotenuse is sine theta. So let's write that down. Sine theta is equal to opposite over hypotenuse. Next, I'm going to substitute in my known values. Since I do not know what theta is, let's just leave it alone. Opposite is 3 and hypotenuse is 5.83. I cannot do anything with the left side of the equation right now, so let's just leave it alone. 3 divided by 5.83 is 0.51 approximately. Since I want to figure out what theta is equal to, I need to do the sine inverse of 0.51. The sine inverse of 0.51 is approximately 31 degrees. Therefore, theta is 31 degrees. In our sixth example, we want to find the measure of angle C to the nearest degree. So let's label it theta. That would make the side labeled 5 the hypotenuse and the side labeled 3 the adjacent side. The trig ratio that contains adjacent and hypotenuse is cos theta. So let's write that down. Cos theta is equal to adjacent over hypotenuse. Next, I want to substitute in my known values. I do not know what cos theta is, so let's just leave it alone. Adjacent is 3 and hypotenuse is 5. Since I can't do anything with the left side of the equation, I'm just going to leave it as is. And 3 divided by 5 is 0.6. I want to isolate theta, so I need to do the cos inverse of 0.6. And the cos inverse of 0.6 is approximately 53 degrees. Therefore, theta is 53 degrees. In our last example, we want to find the measure of angle B to the nearest degree. So let's label angle B theta, which would make the side labeled 2 the adjacent side, and that would make the side labeled 4 the opposite side. The trig ratio that contains opposite and adjacent is tan. So let's write tan theta is equal to opposite over adjacent. Next, I want to substitute in my known values. I do not know what theta is, so let's just leave it alone. Opposite is 4 and adjacent is 2. I cannot do anything with the left side of the equation, so let's just leave it alone. 4 divided by 2 is just 2. Since I want to figure out what theta is equal to, I need to use tan inverse. And I'm going to find the tan inverse of 2. The tan inverse of 2 is approximately 63 degrees. Therefore, theta is 63 degrees.